Okay, sorry for the technical difficulties. Hello, my name is Donatas, and I'm here going to talk about the Nginx modules. Hacking Nginx module. Actually, this talk is not going to be about the security. I will talk about the hacking in a good way, meaning that source code is your only documentation, or you want to find out how things work by putting trace statements into your source code and logging that to the output and see how it works. So the good news is that the Nginx module API is underway. It's still in progress, and what you get is like a bunch of function descriptions, but not the way how you need to combine them. So this is also a community driven, so things might get improved. So how many Nginx users out there? Okay, how many of you use custom modules built by yourself or by someone else? Nobody's. Great. So basically, who doesn't know, the Nginx is a load balancer and an HTTP and a reverse proxy server. Typical deployment of Nginx looks like this. You have your website and you have your load balancer or proxy servers in front of that. So basically, Nginx distributes your load between your backend servers, can do some caching and stuff like that. It's also famous as being fast. So this is a sample from the internet. How many of you chooses something based on benchmarks on the internet? How many of you have tried to reproduce them on your own environment? Yeah, but actually this is close to true. It's really fast. It's capable handling 1 million requests. This is for the static files with some Linux tweaking also. It is fast because it uses a modern I/O event notification mechanism, such like on Linux it uses epoll, on OS X it uses KQ, on Windows not sure if it's now using I/O completion ports, but when I was investigating it used like simple socket select, which is not very scalable. But anyway, I do not recommend running Nginx on Windows. Yeah. It's also easy to deploy because of its multi-process master-child process architecture. So basically, when you upgrading Nginx, even the binary can be upgraded with no downtime. You just send the USR2 signal, and it does the magic. This is basically a simple script which allows you to update. We'll talk about that later. And of course, it is extendable. You can write modules in C, and there are also many frameworks written which allows you to build your application logic in Lua directly in Nginx. So OpenREST is one of the most famous, I think. It has capabilities to connect to MySQL, to Redis, and many more external services. So basically, you don't even need an application server. Yeah, but today we are going to talk about the modules written in C, because this is, if you know how to write module in C, you can write your own web application framework, right? But anyway, why would you want to extend a load balancer in the context of microservices and stuff like that? Yeah. Good point. And this is one of the reasons why we chose to implement part of our logic in the load balancer, because in a business I work, we have latency requirements which are very strict. Like, for example, the 99th percentile of the web request must be up to 100 milliseconds. Also, if you want to track your custom business metrics, because Nginx is the first layer actually that gets hit, and you can start measuring the latency, start looking into what data it has, and update your business metrics. Also, you can plug in your some kind of default algorithm or pre-calculated values in case your all upstream servers, for example, are down. But you still can do business if you have some default values, for example, in your API. And of course, Nginx is great at handling HTTP. So you can offload that stuff from your backend services. For example, by using some more efficient protocol like CAPNP, protobuf, and stuff like that. Because most APIs I've been working is like messages with predefined content length. So basically, you don't need here anymore anything else. So Nginx architecture, as I've already said, consists of multiple processes. Master, and master spawns its workers. Each process is an event loop. So basically, it's single-threaded, and it works in the same way as, for example, Node.js event loop works. It's not blocking. So every process is composed of a chain of modules. Every module is responsible for something. It does something and passes the processing further to the further processing to other modules. So basically, for example, there's event module, which is responsible for accepting the connections. All the connections are accepted by master process, and then they are sharded and balanced to its child worker processes for further processing. Yeah, each module has configuration. Configuration entries are called directives, and those directives can be grouped into contexts. Contexts form a hierarchy of the configuration. So basically, you have a main module, events, mail, HTTP, server, location, and the upstream. We'll talk about that later. So, for example, here you see a config example, which for the main module says that I want to have like 16 worker processes. For HTTP, that I don't want to log not found errors. For server, that I want to listen on port 80. And for the location, that I want to activate a hello module and pass for it custom configuration parameters. And there's my upstream backend configuration. There are three types of modules: handlers, filters, and upstreams. So handler modules basically reads the request and generates the response. Filter modules could be used for enriching the handlers, for example, by adding some custom headers. And also these filter modules can be chained. That means that when one filter finishes processing, the processing is passed to another filter. Upstream modules are responsible for choosing the server which I want to send the load. Also transforming an HTTP request to the upstream server if needed, and receive a response and transform it back to HTTP. So basically, let's switch to the demo. How many of you familiar with the Unix build system and make files? Okay, so this is basically a minimal stuff you need to write an Nginx module. So I have a simple make file, which is basically a project file, as if there are any Visual Studio users and MS Build users, right? So basically, what I have here is commands which are executed when I run make. So basically, what it does, it downloads Nginx source, adds your Nginx custom module source, because the modules needs to be statically linked, and you cannot ship a module by module. As far as I know, currently you can have stuff like that, like dynamic modules, but in this case we'll look at the example where we compile and ship the whole Nginx binary. So basically a make file where I'm providing an Nginx version which will be used to get the sources for Nginx. Also various options, the modules that I don't want. So this is where the download happens and some additional steps. So this is the make file. Also, I need to tell the Nginx build system how to plug in my module, meaning that I need to tell where my sources of modules are located and how I will name my module. So the config. The config for the Nginx. Basically, this section says that if I go through localhost on port 8080, I will get my module hello activated, and it will be generating the response, which in our simple demo example is like putting hello to the output. The source code. Basically, the API of the modules are quite simple. It's written in C, but it has its own memory management, so you don't need to do mallocs, callocs, and stuff like that. You just say that for this request, I need some buffers where I will put my responses. And it will, Nginx will put that memory back to pool after your request ends. So the minimal stuff you need is like a context, which has a bunch of handlers where you can plug your custom logic while reading the configuration. Anybody can't see the code? Is it okay? The font size is good? Yeah, so basically this is a module context. Then a forward declaration for the module initialization, and the commands. Here I have like saying when you see a word hello in Nginx config, please activate that module. And also I'm saying that this is valid for the location configuration, which is here. So if I put hello there, Nginx will say that this is wrong. And also I'm saying that my module will not accept any args. And I'm passing a pointer to my handler. And again, some stuff needed for the Nginx to know better about my module. Okay, so here I'm reading the configuration. And basically this is where my business logic is. There I said that I will return HTTP OK, content length. First Nginx sends the headers. Then I'm allocating buffers and sending to the other modules. This is something like that. Any questions about that so far? I can show that it's working. Basically, now it's downloading the sources.
It's on configuration that you disable master
Yeah, so master process is disabled. It is useful to do so while you're developing, because when you're debugging something, you want to work with the only process. You don't want to fiddle with like 12 of them, because it's difficult to debug. You don't know which worker process will accept the connection, so it's easier. Okay, so I have a simple run script here, which basically sets some paths. I'll just do run. As you see, it's logging a bunch of events. And if I do, I get the response and a bunch of debug information, like which buffers were used, what headers were sent, and stuff like that. Okay. Any more questions?
regarding response headers. I saw that there was
Which part?
This line, 85.
So basically, these are, I'm saying that I want to send the response headers. Basically, the request struct is like a context for everything in Nginx. It doesn't necessarily mean that you're sending the request headers. Okay, so I'm checking for the errors. Yeah, so basically, load balancing in AdForm. This is a company I work. AdForm does ad serving business. And this is the example of one of our biggest APIs with the very strict latencies. And you see that here we have like almost 1.75 million HTTP requests per second. This load is currently handled by 12 Nginx instances with our custom modules. So how did it all started? Like why we moved to Nginx? Because initially we used LVS, all Linux virtual servers, for the load balancing, which are very primitive load balancing, level 4. And it worked really well until we needed an SSL offloading. So basically, that means that you have to handle all your SSL stuff in front-end servers, and the back-end works in a plain HTTP, for example, or in a custom protocol. You don't want to have all that certificate stuff on your back-end servers. At that time, the alternatives was like HR proxy, which was version 1.3. And at that time, I mean like 2 years ago. And Nginx was at version 1.8. HR proxy 1.3 didn't support the SSL offload, so it didn't fit our needs. And there were some other commercial alternatives, expensive ones, and yeah. We were impressed by the Nginx performance, SSL offloading, of course. And another thing that catched our eye was like extensibility and ability to build our very own load balancer. You know, we just were fascinated and attracted by several Hello World module examples. So, and it looked cool until we started to develop. And actually, when you have no documentation or any right way how to do something, you like having many variants of your code which works, but it might work in one case, but in another not. So basically, in this example, if I remove all these additional checks, it still will work. So how we are ensuring that everything works anytime? How do you test the web server, the server which works with the TCP? How do you write unit tests for the TCP stack? Anyone? Yeah, so basically this is the way we did. We treat Nginx process as a black box and write tests which sends and generates HTTP requests to Nginx and inspects the responses. For for that, we have a small testing framework, which is written in Scala. At first, it might look a little bit overhead, but the code is readable. And what you get from Scala, like property-based testing, where you can generate random requests and catch many cases that you don't expect. So basically, this is an example. What you see here is a test for huge request bodies. I think it's readable and self-explanatory. Basically, what this test does is launches the Nginx with the upstream server, which responds with the mocked responses. So you create a request, send to it, get a response, and validate. The framework uses actor system underneath. Basically, it's a little bit of overhead, but still it catched us many errors because it's capable of catching like segmentation faults, memory leaks, and other stuff that you cannot predict. Also, what's helpful in testing is like generating a huge load and leaving it for 20 hours, for example. You run a benchmark for 20 hours. And you see that you're leaking memory, for example, or you don't. So simple techniques that helps us to ensure that our Nginx with hacked modules works. Debugging. You compile your modules with debug option. And if you have a crash, you analyze it with GDB. We run Nginx's with O0 compiler flags in production because we didn't see any significant performance drop compared to O3 optimizations. Basically because Nginx is not CPU bound, it's IO bound, so CPU has nothing to do there, basically. And when it goes down, actually, with a segmentation fault, for example, it still continues to work because basically a single worker process goes down. Other workers are still accepting connections and processing the requests. So basically, you can take a core dump from production, do a GDB, and analyze. We had such case, like classical bug, buffer overflows because of huge headers. But we managed to find out that very quickly. Nobody noticed. So basically, you can debug stuff in production. And of course, to find out how it's working, you can put log messages into the source. So basically, the modules we build is doing for us sophisticated load balancing, like choosing the node that is alive and fast. Because as I've already mentioned, we have strict latency requirements. And for example, if you have like 2-second GC pause, it's not okay because you have to be under 100 milliseconds. Also, we have modules which analyzes just before the backend gets hit. It analyzes and pre-parses the requests or responses and decides if he can respond with the default response. And also waiting for the backend for maximum 100 milliseconds. And if it doesn't respond, we respond with the default response. Some modules we used is upstream check module. Basically, we pimped it with our custom logic. It provides the health checking. This is, for example, it's not very nice, but basically here you can see the load balancers. The IPs are removed for the security, and here you can see the backend servers. Green means that all of them are alive. And if you have red, means it's dead or it's slow. For the request response parsing, we used Jasmine, a lightweight JSON tokenizer, HDR histogram for the latency tracking. Any users of HDR histogram in Java or C# here? Cool. So basically, it's quite cool lib for calculating percentiles in a very efficient way. All the stats provided by the endpoint for each load balancer. As you can see, we have our custom even HTTP errors, which has a special meaning for us. And all those stats are aggregated by Graphite engines and sent to Graphite metrics. So yeah, as I've mentioned, the difficult part here is having the official documentation, because it's driven by the community. I found those 4 links the most useful ones. The first one is like the oldest, but very thorough. And if you want to learn more about how you could develop Nginx module, you should read it. Also, you can take a look how you should do a non-blocking calls to your external services from the Nginx. You can have a look at MySQL module. Basically, this module allows you query MySQL database from your URLs and requests from JSON. If you understand Russian, you can read this article about data structures that are used in Nginx and the official module API. So this is it. Thank you. Any questions?
So you've mentioned that you have 12 load balance. What's on top of that?
You need, you mean like what you use to load balance between load balancers, DNS load balancing.
I have a question about the object pooling Nginx. That you create some buffers. Are they predefined size, or you need to check, for example, if you need a buffer to use 2 megabytes or 2 kilobytes? How is it managed by Nginx? Which size of buffer?
Basically, you can specify the size you want by calling another function. So basically, there's an API which allows you to specify the size. So if you start reading the request and you don't know the length, so you assume that you can chunk them, for example, into 500 kilobytes. It's up to you.
And is the full size limit for how many buffers?
I don't know. We didn't hit such limits, so basically it's just like 1 or 2 buffers.
You mentioned that you are writing integration tests. So when you do integration tests, do you somehow simulate the backend errors like latency or?
Yeah, we simulate the backend errors. We can, for example, I don't know if. So basically, the framework I showed allows you to say that for that backend, please return, for example, 503. And it's our own, but it's like 200 lines of Scala code. So. I mean, you can use anything you want. For example, you can write tests in Ruby, for example. The main idea is like spawning Nginx process, spawning the backend server, sending the request to Nginx, seeing what's the result. I mean, you could do this in Go, Python, and stuff like this.
So you mentioned that you're watching for slow backend nodes. So what do you do when you find slow? You remove it temporarily?
Yeah, we remove it for a temporary time, and when it's done, it's GC. Nginx does the checking, saying that, are you ready? Are you ready? Yes, I am, and here's your load. So basically, this is how we do releases and stuff like that.
And SSO, I guess you were talking most about ad tracking, where if someone reads that information,
No, basically, this API is related to ad tracking, but it's not acquired directly from the web page when you see the ad. It's basically this load 1.75 million is generated by our partners like Google, AppNexus, Microsoft.
Memory leaks, you said you just run for a long time, so you take a measure at the beginning and at the end.
Yeah, because if you run tests for 20 hours, generating random load, you see unexpected if something's wrong with your code. So.
Do you still get any above 100 seconds?
Sorry?
Do you still get anything above 100 seconds?
Yeah, of course. There's always things to improve, and metrics in Nginx helps us to identify the problems.
Like what could be the problem? Do you like apps?
You mean in Nginx?
Yeah.
No, actually, it works like a charm because it's just like. That's why you should write such systems in C. That's why we have not chosen to do things in Lua, for example, as I showed with OpenResty, because here, you can be less productive, but performance is the key. So.
So when you're collecting metrics in Nginx, do you persist them somewhere? Or
We send them in Nginx. We keep them in memory. We always increment the counters, and all the calculations, like how many requests per second, are done by a graphite, which periodically snapshots the stats from Nginx's and does all the math.
You mentioned that like it's mostly I/O bound, right? So like it's really like a big difference between Lua and C.
We haven't measured the difference between Lua and C, but we measured the difference between the compiler optimizations, O0 and O3. At that time, as I mentioned 2 years ago, that OpenResty framework was not very production ready, I would say. So. No more questions? Okay, so thank you.